Most of the music we listen to today is built using what we call the Western 12-tone musical system, a system built around 12 different notes. And between those notes are spaces musicians call intervals. The smallest space between two notes is called a semitone, such as C to C, E to F, A to B flat. And since there are 12 different notes, we also get 12 different intervals between them. Here's a few examples. A major third, a perfect fifth, a minor sixth, each one with its own sonic identity, color, and role in music. Intervals deserve a much deeper explanation, but that lies beyond the scope of this video. For now, there is one interval I want to focus on, the octave. Because, unlike every other interval, the octave brings us back to the same note. Different in pitch, yet still the same musical note. Once we move through all 12 notes, we begin again a new cycle, and the spaces between those matching notes is what we call an octave. But what exactly is an octave, and where does this relationship come from? Years ago, I remember asking myself those same questions, and when I found the answer, it completely changed the way I looked at music. Because as it turns out, the octave has less to do with music theory and much more to do with the nature of sound itself. So before we can truly understand the octave, we first need to understand sound. At its core, sound is vibration. Whenever something vibrates, a guitar string, a drum skin, a loudspeaker, or even our vocal cords, it disturbs the air around it. These disturbances travel through the air as waves. And when those waves reach our ears, we hear sound. But since sound is invisible, one of the best ways to imagine how it behaves is to think of an object falling into still water. Ripples spread outward, carrying energy through the water. Sound behaves in a surprisingly similar way. But to better understand what's happening, let's look at sound in its most basic form, the sine wave. A sine wave is a pure tone, and this is its visual representation. A pure sine wave is rarely found in nature. Most sounds are far more complex, but to keep things simple, we'll use this waveform to explain what comes next. Pitch. Notice its shape, a repeating motion up and down. Here's a simple graph showing one complete cycle. The vertical axis represents how loud the sound is, and the horizontal axis is time. What you're seeing here is one complete vibration, what we call a cycle. And what determines pitch is how many of these cycles occur in 1 second. The more of these cycles we have in 1 second, the higher the pitch becomes. We call the number of cycles per second frequency, and frequency is measured in Hertz. 1 Hertz means 1 cycle per second. Every musical note corresponds to a specific frequency measured in Hertz. Here's an example of a violin playing the C major scale starting from middle C. Notice as the notes rise, their frequency rises too. Now let's take one note, the A above middle C, A 440. This note vibrates at 440 cycles per second, or 440 Hertz. Now let's double that frequency. 440 becomes 880 Hertz. Where do you think this note will appear? The same note an octave higher. Now let's go back to 440 and divide it by 2. 220 Hertz. Now where do you think this note will appear? Again, A, the same note 1 octave lower. Do you notice something? 220, 440, 880. Each frequency is exactly double or half of the next, a precise mathematical relationship, And this relationship is exactly why these notes are the same note at different registers. This is an octave, the doubling or halving of frequency. Over centuries, the Western musical system gradually settled on 12 equal divisions of the octave. This offered a remarkable balance of harmonic possibilities, mathematical relationships, and flexibility. But this is far from the only way to divide the octave. Around the world, many musical traditions divide the octave differently. Some use fewer notes, some use more. And many do not divide pitch into equal spaces like the Western system. The possibilities are nearly infinite. One final detail. The word octave is actually a Western term. It comes from the Latin word octo, meaning 8. So now, if you're wondering why the octave is called what it is called, when we established that there are 12 different notes, it's because in Western music, we often organize notes into 7-note scales. And when we return to the note we started from, we arrive at the 8th note. And of course, these scales can begin from any note. But regardless of how we divide the octave itself remains constant, a relationship rooted in the nature of sound itself. The octave wasn't created by music theory. Music theory grew around it.